I'm so glad you could join me again here at Math Rocks with Mr. Cox. This video is going to focus on the unit circle, and it's the first of three parts. And in this video, we're going to be looking at a couple different old topics and how they relate to the unit circle. Those topics are special right triangles, along with sine, cosine, and tangent, those trig functions that you learned about. And then we're going to be applying them to certain angles within the first quadrant of a unit circle. So, stick around and find out all about it. Let's get it on! So, first of all, you're probably wondering, well, what is a unit circle? Well, it's a circle with a radius of 1. And you'll notice here we have the center here, and we also have a coordinate here, which would be x comma y. And obviously, this angle can change, which would also change the coordinates of this point. And we're going to be relating this back now to special right triangles, and you'll see how this all fits together by the end of the video. So you have learned the special right triangle for a 30 and a 60 and a 90, and also a 45, 45, and 90. And they look like this. If this is x, because it's across from 30 degrees, the hypotenuse was 2x, and across from the 60, this would be 60 over here, would be x times the square root of 3. And let's go ahead now and let's think about it in terms of a unit circle. So in a unit circle, the radius is 1, which, by the way, this would be our center right here, and out here would be our point, x comma y. So this 2x actually in a unit circle would have a length of 1. So that means 2x equals 1, and that means that x would be half of that, or just 1/2. And it also means that the one opposite the square root of, the one opposite 60 degrees would be x times the square root of 3, which would end up being the square root of 3 over 2. So those would be the exact values of each of these lengths here. They're not approximate values where you could just punch in something on the calculator like sine 30 or something like that, but these are the exact values. For 60 and also a 30 and a 90, it would be the same, and the only difference is if this is the center and out here is the point, is opposite 30 would be your 1/2, and opposite 60 would be square root of 3 over 2, and your radius would still be 1. And then let's take a look over here at the 45, 45, 90. And in a 45, 45, 90, you should know that these two lengths right here of our legs are x, and this would be x times the square root of 2. Well, once again, we do know that if this is our center, and that's our point out here, what it means is that now what we can do is we can say, hey, this length here, the hypotenuse, must be equal to 1. And so over here, I'm just going to go ahead and solve that right here. So we have x square root 2 equals 1. So we're going to solve this for x. So we're going to divide both sides by the square root of 2. So x ends up being 1 over square root 2, which is fine, except we should rationalize the denominator. So if we went ahead right now and multiply top and bottom by square root 2, what would happen is we would get the square root of 2 over the square root of 4, and the square root of 4 is just 2. So that means our hypotenuse, our length here, is 1, and each of these side lengths is going to be the square root of 2 over 2. So we're going to be using this information here where every single time the radius or the hypotenuse is 1 in the unit circle to find exact values for certain functions like sine, cosine, and tangent of certain angle measurements, theta over here. Okay, now the second thing we wanted to talk about right now is understanding once again how this relates to sine, cosine, and tangent. And you know that we have our unit circle over here, that if this is our center and this is our point, x comma y over here, what we're going to do is we know that if we were just dealing in trig functions here, we know that sine is opposite over hypotenuse. Well, because this point is x comma y, it means this distance along the adjacent side would be whatever x is, and therefore this distance over here, the opposite side, would be whatever y happens to be, to get this coordinate of x comma y, because we're going right x and we're going up y. And then also the hypotenuse is whatever the radius is. So that means sine, I know we know it as opposite of our hypotenuse, but in terms of a unit circle, it actually is going to change a little bit. Opposite is no longer opposite, it's now going to be y. And also hypotenuse is no longer hypotenuse, it's now r. Same thing for cosine. It was adjacent over hypotenuse, but now it's going to be x over r. And then finally, we have tangent, which would be opposite over adjacent. Well, opposite is y, adjacent is x, so that's going to be y over x. And now, in terms of a unit circle, because the radius is always equal to 1, technically, if we take y divided by 1, we just have y. And if we take x divided by 1, we just have x. So in a unit circle where the radius is 1, sine is equal to y, whatever y is. Cosine of that angle is equal to whatever x is, and tangent of that angle is equal to y divided by x. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. And so finally what we're going to do is look at how this all fits together, the concepts of special right triangles and trig functions. I've gone ahead now and drawn just the first quadrant of that unit circle. And I've marked in the degree measurements of 0 and 30 and 45, 60, and 90. And these coordinates come from the special right triangles. So here's what I mean by that. If I were to drop down a height here, make this 90 degrees, this would be a 30 and a 60 and a 90 degree triangle. And we know that along this side over here would be the square root of 3 over 2. And that's x. That's why this coordinate here is square root of 3 over 2, and then the height would be 1/2, which is the 1/2. Same thing, if I were to drop straight down here for 45 degrees, I know x and y will both be square root of 2 over 2, and therefore 60 would be the reverse of 30 degrees, so I just go ahead and reverse the coordinates there, and once again, I'd go over 1/2 and right up square root of 3 over 2, and I've done the same thing for 0 degrees. We're going right 1 up 0, and at 90 degrees, it is 0, 1. So why do we need to know these coordinates? And here's why right now. I know sine, by definition in a unit circle, is going to be whatever the y coordinate is, and cosine is going to be the x coordinate. Tangent is going to be y divided by x. So let's take a look at this here. So if I look at 0 degrees, I know my y is 0, so that means sine of 0 degrees is 0, and I know my x coordinate is 1, so that means cosine 0 degrees is 1. We'll worry about tangent in a minute here. Let's continue the process here. So for sine at 30 degrees, it will be 1/2. And if you were to try this right now in your calculator, try sine 30 degrees, and I bet you get 0.5, which is what 1/2 is. If you were to do for cosine of 30 degrees, it's going to be the x, so that's going to be square root of 3 over 2. And then let's see, 45 degrees, x and y are both going to be the same. So y is square root of 2 over 2. X is also square root of 2 over 2. And then when we get to 60 degrees, y is square root of 3 over 2. And then x is 1/2. And finally at 90, we have y is 1. So that's what sine is. And you can try that. Sine 90 degrees, I bet you, is 1. And if you did the x there, that would be 0. All right, so now let's talk about how tangent works here. So tangent is going to be sine divided by cosine, or y divided by x. So 0 divided by 1, well, 0 divided by anything is just 0. So that's what tangent is for 0 degrees. If you do 30 degrees, it's going to be 1/2 divided by square root of 3 over 2. They both are divided by 2, so you can kind of ignore that, and you're going to get 1 over square root 3. And we're going to rationalize the denominators here by multiplying top and bottom by square root 3. So therefore, I'm going to get square root 3 on top. Bottom will be square root 9, and the square root 9 is just 3. Over here, these are both the same. So when I take y divided by x, oh, they're the same. So tangent of 45 degrees is 1. And then when I move on to 60 degrees, it will be sine over cosine, or y over x. We can ignore the 2's, so it'll be square root of 3 over 1. Which is just the square root of 3. And finally, on the last one, 90 degrees. We're going to do 1 divided by 0. And as you know, you cannot divide by 0. It is impossible. So if you try tan 90 degrees on your calculator, you'll get an error message. So we call that undefined here. So now you've seen how special right triangles and trig functions are used on this thing called the unit circle. And if you stick around for part 2, which I hope you do, you'll learn about how this affects the other 3 quadrants and how similar they really are. So thanks for watching, and I look forward to having you do part 2 as well.